In December of 2018, I was commissioned to build a dining table and a matching set of dining chairs. At this time, the only experience I had building chairs was a sculpted rocker that I built in late spring of that year. I spoke with my friend Philip Morley and met with his mentor, Michael Kulka, a furniture maker based out of Austin, Texas. I fell in love with his Medina chairs and asked if I could make a visual replica of his chair for my client. He happily agreed, and I set out to create a prototype out of poplar. I didn't take any measurements. The prototype I created was based off of photos that I had of the chairs and some reverse engineering based on what I know about human dimensioning. I was very pleased with the prototype, and so was the client, so I prepared myself to produce a set of 2 armchairs and 4 side chairs out of my small garage shop. When I built the prototype chair, I made full-size drawings on graph paper and then digitized the drawings into vector format using a free program called Inkscape. I hired a sign-making shop with a CNC spindle to machine all of my templates. This saved me a ton of time, and yes, of course, I could have hired the shop to cut out all the parts for me, but I really wanted the experience of batching out the chairs and developing my own methods of production. The cost of producing the templates was minimal. I provided the plywood and MDF and paid for an hour's worth of shop time. If I were to produce these templates at my shop, it would have taken me hours to produce, and they would have been less than perfect fitting. And I really needed these templates to be perfect in order for the chair parts to fit together properly. All of the jigs I developed for building these chairs depended on these 13 templates, so it was well worth the cost to have an outside source to produce them. The lumber I used to make the chairs was 8/4 and 6/4 Pennsylvania cherry from Irian Lumber Company. It was important that I get the most amount of yield from the rear legs. I lined up the flat portion of the rear leg template to the edge of my lumber in order for me to get several pairs of nested legs out of an 8-inch wide board. The front rails, side rails, back rails, crest rails, arms, and back splats were all very easy to rough out because they were simply just square parts that would be shaped after joinery. The nested rear legs, however, were separated on the bandsaw, and that's why you see them here with such an odd shape to them. Don't worry, the milling process will get 3 of those sides square and ready for shaping. Each part of the chair had to be milled to an exact dimension in order for the jigs that I developed for production to work to my advantage. The rear legs were first surfaced flat on the joiner and then planed to a final thickness of 1.5 inches on the planer. I then jointed the front edge of the rear leg, which in turn will become a reference surface on my pattern routing jig. This surface would also get a large through tenon connecting the side rails. Next, I went to the miter saw to true up the bottom of the leg, and with the flat of the edge of the leg blank pushed up against the miter saw fence, I traced the outline of the leg template. I then set up a stop block to make repeatable cuts and cut the top of the leg at a 7-degree angle to match the angle of the swept chair back. At the bandsaw, I rough out the curve of the rear legs, splitting the marker line and leaving just enough for my flush trim bit to clean up for a machined surface at the router table. The pattern routing jig I made forms both the back and front profile of the rear leg. I first route the back profile, making sure the flattened machined surface and the top and bottom of the leg are referenced off of the stops. The leg blank is clamped into place using toggle clamps, and I make sure there is a portion of the pattern jig in front of the workpiece and at the exit of the workpiece for the bearing to engage and disengage. This allows me to apply pressure against the bearing and start a clean, tear-out-free cut. Once I complete the back profile, I transfer the piece to the other side of the jig and route the front profile. It's pretty much more or less of the same method for not only the rear legs, but also for the front rails, side rails, back rails, crest rails, arms, and back splats. In fact, actually this method is repeated for pretty much anything that had a curved shape. Just keep that in mind when I show this method later on. And there you have it, 16 identical legs, and yes, I made 4 extra legs, just in case I screw something up further into the process. The side rail gets joined to the back leg using a through tenon, and the back rail gets joined to the back leg using a 1/2-inch tenon that's reinforced with 2 screws to draw the joint together. I'm going to be doing all this joinery using the Panto router, so let's go ahead and show you my setup. If you're unfamiliar with the Panto router, I suggest you look up Matthias Wandel's YouTube videos, who invented the original machine. The Panta router houses a standard router in an articulating carriage. The carriage moves according to a follower bearing guided by a template to machine both the mortise and tenon, and it does this very accurately with repeatable results. The Panta router can produce a myriad of other types of joinery, but I used it primarily for mortise and tenon. To hold the back legs to the machine table, I made a fixture to locate the through mortise for the side rails and half-inch mortise for the back rails. This jig did both operations. I first machined the through mortise by clamping down the leg to the fixture and making sure the leg was properly referenced against the location blocks. To cut the mortise for the back rail, I readjusted my leg and lined up my center line to the center line of the jig and reset the depth so that I could do a half-inch mortise. As you can see, having the dust shroud greatly increases the effectiveness of the vacuum, but obviously decreases what you, the audience, can see. The two back legs are joined together by the crest rail and back rail. I first joined the back rail, which was clamped to the machine table without any special fixture. With the bearing riding along the outside of the template, I cut the profile for the tenon, removing slightly more material with each pass. And here's the test fit. Perfect. Next, I moved on to joining the side rails and front rails to the front legs and back leg assembly. The front legs received a pair of half-inch wide by 1-inch long double mortises. I simply aligned the template to the centering scale of the machine, locked the workpiece down, and went to town. Again, I used a shop-made fixture to register the front legs and locate the mortises for repeatable machine operation. The front rail received a mating double tenon, and just like the back rail, the front rail did not need a special fixture. I just used the included self-centering fence. The side rails are splayed out to 7 degrees. I marked the ends of the side rails with my bevel gauge and then used that setting to bevel the blade on my table saw. Both ends of the side rails were cut parallel to each other at 7 degrees. The table on the Panta router was also tilted to 7 degrees, and the back of the side rails received the long tenon that joined to the rear leg, and the front of the side rails received the double tenon that joined to the front leg. A quick test fit to make sure everything came together properly, and we have something that's starting to look like a chair. The crest rail was the next piece that needed to be fitted, so again I used a fixture to register the workpiece on the Panta router and machined the through mortise, and then profiled the tenon on the crest rail. Now the rear legs also received a recessed cut to thin the chair back, which terminated with a cloud lift. I made a stop cut on the table saw, and then finished the cut on the bandsaw. At the bench, I used my block plane and rasp to clean up the bandsaw marks. The cloud lift repeated a profile that was already present on the front of the rear leg. And of course, a test fit of the crest rail. Now there were two parts left to join, the backsplats and the arms for the armchairs. The backsplats were joined to the crest rail and back rail with 1/4-inch wide by 2-inch long slip tenons. I marked the center line of the mortises on all 3 mating pieces. I then aligned them with the center line on the machine table and routed out the mortises. The end of the backsplats are cut at 7 degrees to match the swept angle of the chair backs. Again, the table of the Panta router is tilted to 7 degrees and the 1/4-inch wide mortises were machined. The slip tenons were made out of scrap cherry stock by rounding over the corners of the stock at the router table with an 1/8-inch radius roundover bit. And here is the test fit for the side chairs. The last part that needed to be joined were the arms to the armchair. The center line of the arms were marked, and this time I used a mounting fixture that secured the workpiece perpendicular to the table. I had Max Sheldon at PantoRouter make me a custom square mortise and tenon template. Once the mortise in the arm was machined, I marked the center line on the top of the leg. I aligned the machine with this center line and cut the profile for the square tenon. Before I could join the arms to the back legs, I needed to do a significant amount of shaping. This was done with 2 pattern routing jigs and a tapering jig. I first traced out the top profile of the arms, and at the bandsaw I removed a majority of the waste. I then clamped the arm to a pattern jig and routed the bottom half of the arm profile with the top bearing of my flush trim bit removed. I then flipped the piece, reattached the top bearing, and routed the remaining surface. The front end of the arm received a roundover, and that was done at the disc sander. The inside profile was achieved using the same method, rough out at the bandsaw and pattern route at the router table. Finally, the outside taper was cut on the table saw with a simple tapering jig, and the rounded back edge formed at the disc sander. To attach the arms to the chair back, a 1/4-inch notch was machined to create a lap joint. This was done using a flush trim bit. The rear legs were placed into a locating jig, allowing the bearing of the flush trim bit to ride along the track of the jig. I then counterbored a hole in the arm to accept a screw, which will be covered with a walnut plug during final assembly. With all the joinery done, it was time for shaping, and this involved a combination of jigs, machine tools, and hand tools. All of the exposed tenons received an initial shaping with an 1/8-inch roundover bit. I built a carriage to hold the workpiece in a vertical position while routing at the router table. I even incorporated a 7-degree ramp to round over the large back tenon. All of these exposed tenons will be wedged with walnut, so there is still a significant amount of shaping that needs to occur, but this will at least give me a head start during final assembly. The front legs, front rails, side rails, back rails, crest rails, and back splats were all initially shaped using the same method. The templates were traced out onto the workpiece, they were then roughed out on the bandsaw, and pattern routed at the router table. One thing I wanted to mention was that all of my profiling jigs were designed to be used in a downhill cut to prevent the possibility of tear out. That said, there were a couple of occasions where I made uphill cuts at the router table, but these were small cloud lifts with a minimal chance of causing a catch or any significant tear out at the router table. To cut the serpentine curve for the multiple backsplats, I created a shop-made jig that uses the backsplat template as a guide on the bandsaw. I adopted Michael Fortune's bandsaw finger guide jig as a starting point. I attached the template on the flat side of the backsplat and I drew the pattern on the inside curve as a visual guide. The inside finger guide is slightly proud of the bandsaw blade, leaving just enough material to be worked by hand. The outside finger guide offers additional tracking, balance, and workpiece support. This gives me some form of repeatability and reduces the amount of material I'll need to remove by hand with a spoke shave and card scraper. Also, a little bit of furniture wax on the finger guides helps things glide smoothly. The inside and outside curves on the crest rail and back rail, I used a similar method. I made mating templates for all of the inside and outside curves that were mounted onto the bandsaw. The workpieces were mounted through the tenons to a jig that matched the curvature of those templates. The tenons would either accept a screw or be wedged during final assembly, so the integrity of the tenons were not compromised in any way. Once the inside curve was cut, I simply replaced the bandsaw template with a concave template, and then removed the workpiece and put it onto a new jig. This allowed me to make repeatable concave and convex curves for the crest rail and back rail, and greatly reduced the amount of handwork I had to do at the bench. I used the spoke shave and card scraper at the bench to remove the bandsaw marks on the curved pieces. To hold the back splats in the vise, I attached some spare loose tenon stock onto some blocks. This allowed the pieces to be secured from each end of the backsplat. And to hold the back rail and crest rail, I simply screwed the pieces into the bandsaw jig and used that as a clamping caul. Working at the bench is pretty therapeutic, and overall it's probably one of the more enjoyable points of this whole build process. I also added a tapered leg indent using a method I learned from Daryl Peart. It's simply a bracket that fits over the leg and has an 1/8 inch shim on the end to create a ramp. The 5/8 inch bushing creates a spacing between the edge of the leg and the indent, and a 1/4 inch mortising bit routes out that indent. It's a very fine detail, but one that I thought really added a lot of character to the chair. Before I could sand everything and prep for finish, I had to add a roundover to all the pieces. The back splats received a 1/4 inch roundover, and I used the starter pin on my router table to balance the back splat in the vertical position as I was doing the routing operation. For areas with a lift or recess that needed a roundover, I double stick taped shims on the router table to support the workpiece. I then raised the bit enough to engage the bearing and cut the roundover profile. This worked especially well on the rear legs, which had a nice cloud lift on the interior. After literally hours of sanding, which I won't bore you with, I cleaned up the surface of the workpieces using a vacuum. The loose tenons were pre-glued into the backsplats, which offered a ledge to rest the pieces while applying a spray finish. I also covered the tenons with blue painter's tape and screwed in eye hooks in concealed areas to allow the workpieces to hang from a ladder during the spray application. I ended up using Sherwin-Williams Bright Rub conversion varnish and applied 2 coats of finish prior to final assembly. I did apply 1 final coat of finish after final assembly to coat the exposed tenons, wedges, and plugs. I used hide glue to assemble the chairs for its long open time and reversibility if I ever needed to make a repair. The pieces went together without any issue, and that's mostly due to the fact that I already built a prototype and figured out the methods to reproduce and repeat. The legs, front legs, and back of the arms all received screws for reinforcement, and walnut wedges were used and driven into the exposed tenons on the arms, side rails, and crest rails. Walnut plugs were also glued and driven into place to cover the screw holes. All of the wedges were flush trimmed, and the surrounding areas of the exposed tenons were taped off with blue painter's tape to protect the finish. I used a chisel to pare away the corners of the wedges and then used the Festool Rotex sander with a soft interface pad to pillow the exposed tenons. Finally, concave sanding pads were used for the final touches and polishing. Even though I didn't show this process, the chairs received that final coat of conversion varnish after the wedges and tenons were shaped. To support the seat inserts and reinforce the corners on the chairs, I used corner blocks. The corner blocks for the front legs were cut on the miter saw, while the curve to the back corner blocks were cut on the bandsaw and finessed at the disc sander. The corner blocks were then counterbored and driven in with washer head screws. The plywood seat inserts were traced out using another template that I made previously, and like so many of the other chair parts, was roughed out at the bandsaw and flush trimmed at the router table. The seat inserts also received a 1/2 inch roundover to help shape the edge of the foam during upholstery. And finally, a 1 inch relief hole was drilled out to allow the air within the foam cushion to escape. Now, I'm not an upholsterer and I don't pretend to know much about the craft, but I did try my hand at upholstering the inserts. I first cut out the 1 inch Dacron oversized by 2 inches around the perimeter of the plywood insert. I then cut the upholstery fabric oversized by 4 inches around the perimeter of the plywood insert. I used a piece of cambic to cover the relief hole and then glued 1/2 inch foam to the center of the insert to help create a crowned cushion. I then applied spray adhesive to the 2-inch foam and Dacron to prevent them from shifting as I start to apply the fabric. It's then a matter of pulling, wrapping, pleating, and stapling. I started by stapling at the center, then the corners, and then working from the center to the corners, making sure to evenly distribute the creasing and pleating the best that I can. Again, not an expert by any means. Finally, I cut away some of the excess material and apply the cambic dust cover to the bottom of the insert to give a nice finished touch. And there you have it, a set of 2 armchairs and 4 side chairs. Thanks for watching.